Welcome back to Easy Academic. In this episode of the Linear Algebra series, we'll be discussing reduced row echelon form. Now this is an extension of the prior episode where we talked about Gaussian elimination and row echelon form. But there are two main factors that characterize a reduced row echelon form as compared to a row echelon form. So as we discussed in the prior episode, the pivots are very important. But the first property of reduced row echelon form is that all the pivots are 1, as I alluded to in the previous episode. And it's very important that you understand Gaussian elimination and standard row echelon form before we learn about reduced row echelon form. So if you're curious about that, be sure to check out the video in the card. The second property that's very important is that the zeros above every pivot are 0. Similar to row echelon form where the values below every pivot are 0, but as an extension, now if the value for the pivot is not at the top row of the matrix, all values above it must also be 0. So let's look at an example matrix that we've already converted to row echelon form. So this is the matrix from the previous episode, which we've called A tilde, that we already converted to row echelon form. So there's some important things of note when making comparison about why this isn't only in only in row echelon form and not in reduced row echelon form. So firstly, you'll observe that these two pivots, 5 and -1, are not equal to 1. So because they're not equal to 1, that means that this is not in reduced row echelon form. Additionally, these values, all of these other values that aren't the pivots, are all non-zero. So because of these reasons, this is only in row echelon form and not in reduced row echelon form. So with that being said, let's convert this into reduced row echelon form. So first what we'll observe is that the second row, the first pivot, is 5. So we can simply scale the second row. So we can take R2 and transform it to 1/5 of R2. So this will give us the first row is unchanged. The second row is now scaled by 1/5, and the third row is unchanged. Similarly, we can take the third row and scale it by -1. We'll find again the first and second rows are unchanged. And the third row just has this value converted. Now that all our pivots are 1, we can clear out values that are non-zero, that are supposed to be non-zero, in rows above by using rows that are below them. So first we'll clear out the non-zero values above this pivot 1, which is this one. So what we'll do is we'll take 1/2 of row 2 and add it to row 1. So this transformation will look like row 1 being converted to row 1 plus 1/2 row 2, which will look like 1, 0, and then we have 1/2 divided by 2, so 1/10, and then 1/10 plus 3/2. And the second and third rows remain unchanged. What we now need to do is clear these non-zero values above the pivot. So what we'll do is we'll multiply this value by whatever is needed to eliminate the values above it. So in row 2, we'll transform it by So in row 2, we'll transform it by taking it and subtracting 1/5 of row 3, which looks like this. And then for the final matrix in reduced row echelon form, we subtract 16/10 of row 3 from row 1, which looks like this. And so this is our final A in reduced row echelon form. So now that we have our matrix in reduced row echelon form, we can identify these things called basic variables or leading variables and free variables. So leading variables are any column that has a pivot. So this column, and this column are all leading variables. The free variables are the columns that do not have a pivot. So this column, can do that in a different color. So with leading variables, when you solve to identify leading variables, you write them in terms of the free variables. Whereas the free variables can take on any value. This is in the case that infinitely many solutions are present when you have a matrix equation. So that's all for this episode in the linear algebra series. If you have any questions, feel free to ask them in the comments below. Otherwise, if you found this useful, please like and subscribe to the channel.